This battery right here is the perfect example of why I do teardowns on my channel. This is the VTERUN 100 amp hour DC battery box, and I was originally very excited to see how it performed because it has a lot of really cool features. For example, it's the same form factor and weight as other 100 amp hour batteries. However, it has a few interesting connections on the side. For example, you have a 12-volt cigarette port, you have a couple USB ports, and you have a built-in 200-watt solar charge controller. This battery also has built-in heaters so you can charge it below freezing. It has Bluetooth connectivity to the BMS so you can see the state of charge and what's going in and out of the battery. And it's also advertised to have high-quality grade A lithium iron phosphate cells. So everything on paper looked really good for this battery, and even through all of my initial testing, it performed as advertised. But when I tore it down, that's when everything changed. For example, if you remember, they are claiming to be using grade A LFP cells on the inside of this battery. However, when I went to scan the QR codes to figure out where they were manufactured and when they were manufactured, I realized that they ground off the QR code using a Dremel, so I could not track that information. And that's usually a sign that these are not grade A cells. I also looked closer, and two of them had some sort of residue built up on the pressure relief valves, indicating that they are possibly used. Now, the second issue that I found inside this battery was very dangerous, as you can see with this wire right here completely melted and burned. If you remember, this has a 12-volt socket on the side of the battery to power your loads, and as I inspected these wires, it was using 18-gauge wires, and there was no inline fuse to protect if you pulled too much power from this 12-volt socket. This is actually connected directly up to the BMS, which allows 100 amps before it shuts off. So as you pull too many amps, you can burn up this wire and start a fire on the inside of the battery. Now, in order to test out the 12-volt socket to see if it really was dangerous, I connected up a small 300-watt inverter that's powered with a 12-volt plug. After connecting up two heaters totaling about 300 watts of power, within 1 minute of the test, the wires were already smoking and melting, and I measured a temperature with my thermal camera, almost 400 degrees Fahrenheit. Now, I've tested and torn down multiple batteries on the channel, and this is the first one where I've had some sort of safety risk like this, and boy, did that testing get a bit intense. Now, if you want to see the entire teardown for this product, I will include that at the end of the video. I did find a few other little issues during the teardown process, but I shared the biggest issues with you. Now, I'm kind of in a predicament here because I usually don't like to make negative content on the channel, and I definitely didn't plan on throwing this company under the bus, but people have purchased this product. For example, if you look on YouTube, there are other YouTube channels that have tested and even recommended this product without knowing that there was an issue inside. And that's why it's so important to do teardowns. Now, let's say this was a prototype that the company sent out to me. Well, I would have found these issues, and then I would have said, hey, make these changes to make it safe. They would have sent out a second version, and I would have confirmed that, everything was fine. But because this one is already in people's hands and they're testing it, I felt it super important to make the video to let people know that they didn't get exactly what they were paying for with the grade A cells. And also, there's a safety risk with the 12-volt socket. If you happen to short circuit it or pull too much power over those 18-gauge wires, since there's no built-in protection, you have the risk of melting and burning the wire. Now, obviously, I am a bit frustrated with this entire scenario because I've spent a ton of time testing the battery only to open it up and find these issues, so it's not that useful to me. And to find out that people have been purchasing this battery, I bet they're frustrated with the whole scenario as well. So I actually emailed VTERUN with all this documentation. I included pictures and what happened when I tested it and all that stuff. And they responded to me within 24 hours. And even during Chinese New Year, which is a big deal. So this is what they had to say. They said, "We are committed to resolving these issues as quickly as possible and ensuring that our products are safe, reliable, and honest." Now this is important here. It says, we will also be transparent with our customers about the steps we are taking to address these issues. So anybody who purchased this, you'll have to let me know if you get like an email, if they refund you, if they're going to plan on sending out a second version. Let me know how they try to make it right with you, because I'm not a customer, I'm just someone that's reviewing this. But they said they would be transparent, so what does that mean? Continuing their email. "To make things right, we are taking the following steps. Step 1. Discontinuing the current model. We will immediately discontinue the current model to prevent further sales of the defective products." So that's good news. Number 2, updated battery. If you are still interested, we'd be happy to send you the updated version of the battery with all the corrections in place for your review. Overall, I really like the idea behind this product. I think without these issues, it'd be perfect for people that are looking for like a DC power box or a DC only power station. I really like that it has, you know, the built-in charge controller and these outlets on the side. So I think I'm willing to let them make it right. I want to give them a second chance because you never know what you're going to get with a Chinese factory. Like what if they sent out, what if the factory they were working with sent them a couple good versions and they approved it, and then they started making these changes behind their back. So you just never know until, you know, you tear it down. I'm gonna wait for them to send out the second battery, and I will test it and tear it down and see the difference. So I'm really looking forward to the fixed version. I hope they can make these changes. If you're someone that's purchased this battery, you'll have to let me know what you think about this entire process down in the comment section. So for the remainder of the video, I will include the testing results. So all the tests that I did on this battery, so you can see how much capacity I got, how the BMS functions, the heaters, Bluetooth, things like that. And then I will also include the teardown footage, just so we have a good idea of how version 1 is assembled, how version 1 performs. And then when I get version 2, we can compare both side by side and see if the issues were actually fixed. So super interesting scenario, guys. What do you think about all this? Make sure you throw a comment down below. And if you happen to like this type of content and you want to see more teardowns in the future, please smash the thumbs up button. Thanks for watching. I'll see you guys in the next one. So let's jump right into the testing, starting with the capacity test first. Now, I was really excited to do the capacity test on this battery because I just purchased this BK Precision 1500 watt electronic load. This is lab grade equipment, so I can get really accurate results when testing out the battery. With the battery fully charged up to 14.6 volts, I started the capacity test discharging the battery at a 0.2C rate or 20 amps. Now what's really cool about this device is that it logs all of the data during the entirety of the test, and it spits out that data at the end. For example, once the battery was fully discharged and shut off, we pulled a total of 103 amp hours. The test ran for 5 hours and 10 minutes, and you'll also notice that the voltage curve was very flat and steady throughout the entire test. Next, we'll be testing the low temperature charging protection and the built-in heaters on this battery. I left this out overnight. It was around 20 degrees, and in the Smart app you can see the internal temperature is 22 degrees for the battery. So what happens if we try to charge it when it's this cold? Is it going to charge, or is it going to turn on the internal heaters? Let's find out. Okay, so I'm going to hook up the positive and the negative. So you can see that the power supply is not dropping in voltage to charge the battery. It's just putting power directly in. So I think this is working with the heaters. Let's check the app. So up on the screen, you'll see the Smart app. You can see the battery voltage is actually 13.31, and there is no current going into the battery. At the top, you can see the charging MOSFET and the discharging MOSFET are both disabled. But you can see that there is a charging UTP, which I think that means it's putting power into the heaters, and the temperature is already rising on the battery. You can see it's gone from 22 to 23 degrees Fahrenheit. I want to see how long this is going to take to start charging. So I'll set a timer and we'll see how long it takes to get up to temperature. Now on a side note, this is the amount of power that the heaters are taking in, so about 77 watts. I do have this turned up to 10 amps, and it is limiting it to about 5.33 amps. So the battery has 75 watts of heaters inside it. Okay, so it's been about 45 minutes of having the battery charger connected up to the battery. And if you look at the Smart app, it's showing 60 degrees inside the battery, and it is fully charging. So it's been about 45 minutes to get to this point. Now I will say, once the battery was about 42 degrees, it did start trickle charging the battery. And then once it got up to about 52 degrees, it kicked on a bulk charge, and the temperature rise pretty quick after that. So yes, the internal heaters do work, and it takes about 45 minutes if your battery is at 20 degrees Fahrenheit. In my next test, I want to see if this battery can handle 100 amps continuous output. The BMS is rated at 100 amps or 1280 watts. So with my DC electric load here, I'm going to set the amperage to 100 amps. We're going to set a timer for 15 minutes, and we'll see if the battery shuts off. So we'll set this to constant current mode. We're going to put in 99.9 amps and set that limit, and then we'll start the test. So the test has been going for about a minute so far, and up on the screen you'll see a screenshot of the app. You can see it's pulling 99.45 amps. So let's let this run for 15 minutes. I'll check back in later. Okay, so if you take a look at the timer, we just hit 15 minutes. The battery is at 71% state of charge. Sorry, the fans on this unit are pretty loud when it's running this large of a load. But let's turn up the load to see if the BMS shuts off. So you can see the current load is 99.9 amps. So let's put in 105 amps and see if the BMS shuts off. Remember, it's rated for 100, so can we go over it? Oh, look at that. It instantly shut off. So anytime you go over 100 amps, the battery is going to shut off the BMS for discharging. Now, an interesting note here at the end of the test, I touched the positive terminal and the wire, and it was fairly warm. I measured with my thermal camera, and it was showing 127 degrees. So I'm guessing that the conductors on the inside of the battery are a little undersized for that 100 amp continuous load, because the wires that I'm using here are 1/0, and they're rated for over 150 amps continuous. So it has to be the internal wires. So I'm excited to tear this open later in the video and see what they're using for that. Now, what about the connections on the side of the battery? How much power can you get from these? Right here we have a 12-volt cigarette socket. So we'll test to see how much power we can pull from that. We also have a USB-A and USB-C port. So it'd be interesting to see what those are programmed at. And also right here we have a 200-watt MPPT solar charge controller. So let's start by testing this port here. So I have the 12-volt plug plugged into the battery, and I have this wire connected to my electronic load. So let's set up 10 amp load. So 10 amps and start the test. Okay, so we have 10 amps coming out of that 12-volt socket, or about 127 watts. So let's step it up a little bit. Let's go to 15 amps. Okay, so now we are pulling 15 amps from that 12-volt socket, about 187 watts. So that's pretty awesome that you can pull 15 amps from that 12-volt socket. Now this has been going for a couple minutes now, and it's still pulling 15 amps, no issues. So let's turn up the load to 20 amps to see if there's some sort of protection built into this port here. So 20 amps. Okay, so we are pulling 243 watts, 20 amps from that 12-volt socket, and it's not shutting down. So I definitely wouldn't recommend pulling this much power from that 12-volt socket, because usually you'll melt your 12-volt plug or you'll burn up a fuse, but quite a bit of power available from that output. Well, now that we've tested the 12-volt socket, let's move on to testing the USB ports. Now, one thing that I've noticed is both of these are kind of installed a little bit sideways. They're not perfectly straight. Now, this USB port insert looks just like some of the ones you have available on Amazon, so I don't think it's proprietary or anything. You have one USB-A port and one Type-C connector, so let's see how many watts we can get from each one. While connecting into the USB-A port, we are seeing Quick Charge 2.0 protocol at 12 volts. So we are getting 12 volts at 1 amp, or right around 12 watts. Now it appears that the USB-C port is a 20 watt port. We're showing Power Delivery 3.0 at 20 watts. So right under 12 volts at 1.6 amps. Now this power switch on the side of the battery allows you to turn everything on or off. For example, when we turn this off, you lose power to both of these outlets. You also lose power to the main battery terminals and Bluetooth connectivity. Now, I did not forget about the 200-watt MPPT solar charge controller. We'll be testing that here in a minute. But I did want to show you that they give you this adapter here with MC4 connections to connect into your solar panels. In the next section of the video, we'll be testing the internal charge controller on the battery. Remember, it's rated at 200 watts. So I actually have two 200-watt solar panels here. First, we're going to connect up one of them to see what happens on the charge controller, and then I want to connect up the second one in parallel with the first for 400 watts to see what happens if we overpanel the charge controller. Now this adapter right here that's connected to the battery comes in the box, so you can get MC4 connections right into the battery. And looking at the charge controller parameters, it supports 10 volts all the way up to 45 volts with a maximum of 20 amps charging. So let's connect it up and see what happens. Now there's no display on this battery to see what's going on, so you do have to use the Smart app to see. So I'll put that up on the screen. We're currently charging at 13.2 amps and 176 watts. So we're getting 176 watts from that solar panel. That's pretty typical right now because it's actually pretty hazy. Let's connect up the second solar panel to see what happens. So I've just finished connecting up both of the solar panels in parallel and plugged them into the battery. And if we look at the Smart app, we've seen just a small increase in power. So now we're charging at 13.3 amps
or 179 watts. So it appears the limit here is going to be right around 180 watts.
Now this is good news if you want to overpanel the charge controller because it appears to be current limited.
But it is a little bit under the rated power of 200 watts. Now I will say that it's super convenient to be able to connect solar panels straight up to the battery with the built-in charge controller, so you don't have to deal with all the extra wires and things like that. You just plug your solar panel in and you're good to go.
So after a couple minutes with 2 screwdrivers and a hammer, you can pop the lid off. So let's look inside this thing. So I just moved the camera so we can get a good look at inside the battery. And guys, let me tell you, I just love tearing these down. You never know what you're gonna find. Okay, so main positive conductor here. It looks like they're using 2 8-gauge wires rated at 200C. And then for the negative terminal, they're also using 2 8-gauge wires rated at 200C. These are silicone wires. Now, this would explain why this got so hot during our maximum load test. It's just because the wires are pretty undersized. I would love to see 2 6-gauge wires for these main conductors. Looks like the BMS is just sitting in here. Okay, so it has this big piece of foam on top and some foam underneath. So it's almost like it was pressure fit in there when the lid was on it. But without the lid on there, there's nothing really holding it in place. So it does have this fiberglass board to keep it from short-circuiting with the terminals of the battery. Let's see if we can remove this off. Okay. And this looks like a JBD or Overkill Solar BMS. I've seen these before. They seem to work pretty well. You have your main conductors, or the negative conductors, screwed and glued down to the BMS. So underneath the BMS, you have your actual cells. There are 4 of them in a 4S configuration. So we have our main negative terminal right here. We also have our main positive terminal here. They are using aluminum bus bars. They seem pretty thick, and they have nuts that hold everything together with this red sort of glue or sealant to keep the nuts on tight. Now right away, I do notice that the balance lead for the negative terminal is installed on the bottom, which means that little ring terminal is keeping this big terminal from getting a good connection. And it appears that is the same case on the positive terminal. The balance lead is on the bottom. So it's best when you swap that around to have the balance lead on the top so your main conductors can get in the best contact with the battery terminal. I want to see what type of cells they're using here. So let me remove this piece of foam. Okay, so I just removed that foam, and take a look at this, guys. This is the first time I've ever seen this on a battery I've torn down. They've taken a Dremel and they've ground off the QR code, so I can't look up the cell type to see what it is. Now, unfortunately, each one of the QR codes is ground off with the Dremel, so we cannot look at the details. And I was also looking closer at each one of these cells, and it appears this cell right here and this cell right here, I'll throw a couple of screenshots up. Basically, they have residue on the overpressure valves for each of the cells, which is pretty interesting. So maybe they're used cells? I'm not sure. But what's one of the downsides of having used cells or grade B cells? Well, usually they don't have exactly matched capacities. So over time, as you cycle the battery, one of these is going to get out of balance, which brings down the entire capacity of the battery. Now, this BMS does have the ability to balance out each of the cells, but it uses very small resistors. And the fact that these are pretty large cells, being 100 amp hours, if they get out of balance to a certain point, the BMS can't keep up. Now, I did find the high temperature sensor for the BMS. You can see it's mounted to this bus bar using this bit of glue, even though there is a little bit of a gap under there. And right here, this bit of glue is the low temperature sensor. I'm not sure if I'm a huge fan of being mounted next to this terminal, because if you're pulling a large load, this will get warm, but at least it is attached to the cell. They just glued it down here, and for extra protection, they added this extra bit of double-sided sticky tape. It's kind of interesting that it's double-sided sticky tape when it only needs to be one side that's sticky. Now, what about the connections on this side of the battery? You have the 12-volt socket, the power switch, the USB ports, and the charge controller, and boy, did they smother glue on those so they stay put. Now, when VTERUN reached out to me about reviewing and testing this battery, I asked them specifically how much power you could pull from this 12-volt socket and how they limited the current. Well, they told me that there were no fuses inside this and that it was limited by the BMS. Now, I've been looking closely at the wires here, and I think there's a pretty big problem here. First off, this 12-volt socket uses 18-gauge wire. The next problem is, because there's no fuse, I wanted to follow the wires to see where they went. And all the negative wires for all of these connections over here go along here and attach to the BMS over here. All the positive wires connect to the main positive terminal. And if you guys remember, you can pull 100 amps from this BMS before it actually shut off. Now, what does that mean? Well, that means you can pull 100 amps through that 12-volt socket before it shuts off. And it uses 18-gauge wire, which is rated for like 6 amps. And in my test, I was pulling 20 amps through that thing, so I'm sure these wires in here got super toasty.